Okay, so this is the next little video for the chapter on, initial chapter on limits. And in the last chapter, we saw a number of functions, and we were trying to take the limit as x goes to some number. So remember, we wrote it like this. Okay. In that as well, we had whatever the function was, whatever the value of c was. Again, this is an x value. And what we wanted to know is what was happening to the function values, or the height values, or the y values, as you get closer to that. So this, basically what I wanted to do is show you that this doesn't always give an answer. And so there's three cases when this doesn't happen. So I'm just going to walk through each one of these. So when may a limit not exist? First one is if okay, so the first one is going to be if the function approaches separate values on either side of c. I'm going to go through a very specific example. This action happens quite a bit with piecewise functions. Okay. And let's go ahead and so remember again the techniques that we learned from the last chapter, or last little video. We're doing a table, we're doing a graph. I'm going to just go ahead and do a graph, and let's take a look at this. If you need to remind yourself on how to do graphs of piecewise functions, I think I've also provided a few videos for that. Okay, so on the right side of 0, I've got x squared, right? So that's just a parabola. But I'm only graphing the stuff when x is positive, right? Okay, 1 minus x is a line. Here's 1, and it's going to have a slope of -1. Okay, and just to be very careful here, open circle because it's not equal there, closed circle there. Okay. So now, that's the graph. I want to talk about the limit again. So the limit as x equals 0. So what I'm looking at with this is right at 0, what I want to know is what's happening to the function. Well, it looks like if I'm just to the right side of 0, the function is becoming 0, right? It's like x squared. However, on the left side of 0, the function is the line, which is getting closer and closer to 1. Okay, so we're going to say the limit does not exist. D and E is the other thing. And I'm just going to say, because approaches 0 on, let's say, the right, and 1 on the left. So basically I'm saying it approaches 2 different values. Okay, so that's one way that this may not exist. Okay, and the next one is the function may grow without bound, is another way that a limit may not exist. All right. And so what I'm going to do is, let's do this function and I want to do the lim of -1 of this. Okay, and this you may either need to remember back to graphing some rational functions like this, or throw it at Desmos or something. I'm not too particular about this. So what happens with this is at -1, function goes, and we'll talk more about this, but this is an asymptote. But it looks like that. So what I'm looking at with this is as x goes to -1, what's happening to the function? It's going bigger and bigger and bigger and bigger. Okay. So the limit doesn't exist in this case. We're actually going to see these a little bit later as well. I would often argue in this that we're going to say that the limit goes to infinity, which is a sort of very particular part of not existing. Okay, but right now you can just say it doesn't exist. So you can say the n e again. Okay. Okay, and then the last is, oops, let's go 3. Oscillate. Okay, and this is going to be that the function may oscillate as it approaches c. And this is a classic example, sine of 1 over x. And we're going to be interested in the limit as x goes to 0. This is one I would definitely pull out Desmos for. So basically what happens with this is something like this. And I may have some of the details wrong. But the point is, as you get closer and closer, it just oscillates faster and faster like this. So this is a really nice one. Try to go in, like take Desmos and kind of zoom in on this region and see what happens, and you'll see it doesn't actually reach a value. It just keeps oscillating. So this one is also a D in E. Okay. So those are sort of the 3 standard ways when it may not exist. So kind of to sum up this as well as the previous section. Right, you're presented with a function. You're presented with a value of c, like where do I want to find the limit, and then what can happen to it. So from the last chapter we used tables and graphs to try to get some ideas about it, and in all the examples I did there, it gave us actual values. In this section it may not actually do that. So there were the 3 again. So it may approach different values on the left and right, or it may grow without bound, or it may oscillate like this.